Okay, so for the first questions, we're just determining the value of x. So I'm going to start by highlighting my hypotenuse. I'm going to circle my reference angle. And using my reference angle, I'm going to label my sides. So in this problem, we're solving for the opposite side. And we're given the hypotenuse. So OH means we're going to be using sine. So it's going to be sine 45 equals x over 20. Sorry, my dog's making noise. And then we're going to cross multiply. So x equals 20 times sine of 45. And since we already have x by itself, we're just going to multiply 20 times sine of 45. And you get 14.14. Okay, number 2, same thing. We're going to highlight the hypotenuse and circle our reference angle. We're going to label our sides. So 11 is the opposite side, and this blank side is the adjacent. So again, we have OH, which tells me I'm going to use sine. So sine 53 equals 11 over x, and then cross multiply. So x times sine 53 equals 11. And then to get x by itself, we're going to divide by sine 53. And you get, when you do 11 divided by sine 53, you get about 13.77. All right, number 3, I'm going to circle my reference angle, highlight my hypotenuse, and label my sides. So 19 is H, X is A, and this side's the opposite side. So since we're solving for the adjacent and we have the hypotenuse, AH means we're going to use cosine. So it's going to be cosine 50 equals x over 19, adjacent over hypotenuse. And then we're going to cross multiply. So x times 1 is x, and then 19 times cosine 50. And since x is already by itself, we go ahead and put in 19 times cosine 50 in our calculator. You get about 12.21. Okay, number 4, same type of problem. I'm going to start by circling my reference angle and highlighting my hypotenuse, labeling my sides. And in this problem, we are solving for the hypotenuse, and we're given the opposite side. So OH means we're going to use sine. So sine 27 equals 16 over x, opposite over hypotenuse. And cross multiply. So x times sine 27 equals 16 times 1, which is 16, divided by sine 27. So now that we have x by itself, we'd put in 16 divided by sine 27 in our calculator, and you get 35.24. All right, number 5, we're solving the whole right triangle, so we're solving for all the missing sides and angles of the triangle. So for this one, it's a good place to start is start by whatever you have 2 of. So since we have 2 angle measurements, we're going to first solve for the measure of angle A, and we're going to use triangle sum theorem. So the measure of angle A plus 90 plus 64 equals 180. So the measure of angle A plus 154 equals 180, and then we're going to subtract 154 from both sides. So the measure of angle A, 180 minus 154 is 26 degrees. Now we're going to go ahead and solve for our missing side. So I'll first solve for AC first, which I'll go ahead and call X. So I'm going to use the 64 as our reference angle. And using 64 as our reference angle, 14 is the opposite side. AC is my hypotenuse, and which would make BC my adjacent side. So since I'm solving for the hypotenuse, I have the opposite side, that's OH. I'm going to use sine. So it's going to be sine 64 equals 14 over x, and then we're going to cross multiply. So x times sine 64 equals 14, and then divide by sine 64. So we have x by itself. We're going to do 14 divided by sine 64. You get about 15.58. So AC is 15.58. Now I'm going to solve for BC, which I'll go ahead and call Y. So again, I'm going to use my 64-degree angle as my reference angle. This time we're solving for the adjacent side, and we have the opposite side. So OA is tan. So I'm going to do tan 64 equals 14 over Y, and cross multiply. So Y times tan 64 equals 14, and divide by tan 64. So we have Y by itself. We're going to put 14 divided by tan 64 in our calculator. So 14 divided by tan 64 would get about 6.83. So I realize my key's wrong. It says 6.29, but it should be about 6.83. So BC is 6.83. All right, moving on to number 6 and number 7. So it says solve for x two different ways using two different trig functions. So solving once with sine and then once with cosine. All right, so first I'm going to see what the problem gives us. So in problem number 6, 38 is my reference angle. This is my hypotenuse, so labeling my sides, that's H, 18 is A, and this is O. So using the information that we're given, we're going to use cosine since we have the adjacent and we're solving for the hypotenuse. So cosine 38 equals 18 over x, and then we're going to cross multiply. So x times cosine 38 equals 18, and then we're going to divide both sides by cosine 38. So 18 divided by cosine 38, we get 22.84. So if we wanted to solve this problem again, but using a different trig function, we would have to use a different angle. So what we're going to do is we're going to solve for this angle, and that's just going to be 90 plus 38 plus, we'll call it y, equals 180. So 90 plus 38 is 128. And subtracting 128, you get 52. So now I can use this angle as my reference angle. 18 now becomes the opposite side, which now allows me to use sine instead of cosine. So sine 52 equals 18 over x. We should get the same thing when we cross multiply. So x times sine 52 equals 18, and divide by sine 52. And we get the same thing. So x is 22.84. So in order to use a different trig function, you have to solve for the other angle. Because when you switch reference angles, remember your opposite and adjacent sides also switch. Okay, looking at number 7, using the information that we're given, 42 is my reference angle, 15 is my hypotenuse, x is my opposite side, so using the information that we have, that's O and H, which means we're going to use sine, and then cross multiply. So 15 times sine of 42, we get 10.03 or 10.04. And then to solve this again, using a different trig function, we have to first solve for this angle. So 42 plus 90 is 132, and then 180 minus 132 is 48 degrees. So now I could use this as my reference angle. X now becomes my adjacent side. 15 is still my hypotenuse, so now I could use cosine. So cosine 48 equals x over 15, and then cross multiply. So x equals 15 times cosine 48. And we get the same thing. All right, now let's look at number 8 and number 9. So these are both multi-step problems. So remember, with the multi-step problems, the first thing we're going to do is we're going to solve for the shared side, which we can go ahead and call y. So using the triangle on the left, 64 is my reference angle. I'm going to label my sides. Since I'm solving for y, that's the opposite side, and I have 39, which is the adjacent, so OA means we're going to use tan. So it's going to be y over 39, and then cross multiply. So 39 times tan 64, we get 79.96. And now that we have that, now we can use the triangle on the right. 40 is my reference angle. This is my hypotenuse. This is the adjacent side, and this is the opposite side. So in this case, we're solving for the opposite side, and we have the adjacent, so we're going to use tan again. So tan 40 equals x over 79.96, the side we just solved for. Cross multiply. So x equals 79.96 times tan 40. You get about 67.09. Okay, so for number 9, we're going to do the same thing. We're first going to solve for this shared side, which I'm going to go ahead and call y. So using 25 as my reference angle, 16 is my hypotenuse, y is my adjacent, and this side's the opposite side. So I'm solving for the adjacent. I have the hypotenuse. I'm going to use cosine. And then cross multiply. So y equals 16 times cosine 25. And since we have y by itself, we're going to do 16 times cosine 25 in our calculator. We get 14.50. So that's my shared side. Now I can move to the triangle on the right. Using 39 as my reference angle, x is my hypotenuse, this bottom side is my adjacent, 14.50 is my opposite side. So since I'm solving for my hypotenuse and I have my opposite side, OH, means I'm going to use sine. And cross multiply again. So x times sine 39 equals 14.50, and then divide by sine 39. So 14.50 divided by sine 39, we get 23.04. All right, so my key is wrong for that one too. So sorry. Number 9, the key does say that it's 11.11, but it should be 23.04. But if you were in class, you should have changed that on the key. All right, so number 10, we're now solving for the missing angle. So in this case, we are going to be using inverse trig anytime we're solving for the angle. So we're solving for that angle. We're still going to label our sides. So 10 is my hypotenuse, this is my adjacent, and this is my opposite. So I have the O and the H, which means I'm going to use sine. So sine x equals 8 over 10. And then since we're solving for the angle, we use the inverse. So sine -1, 8 divided by 10. And then we just put that in our calculator. So inverse sine 8 divided by 10. We get x is approximately 53.13 degrees. Okay, number 11, same thing. Circle my reference angle, label my sides. So I have A and H, which means I'm going to use cosine. So cosine x equals 3 over 5. And we're going to use the inverse. So -1, 3 over 5. And you should get 53.13. Okay, number 12, circling my reference angle, labeling my sides. So this one I have O and H, which means I'm going to use sine. So sine x equals 42 over 60. So we use inverse sine 42 divided by 60. We get 44.43 degrees. And right, number 13, circle my reference angle, label my sides. So I have OA, which means I'm going to use tan. So tan x equals 1 over 3. And to get my angle, I'm going to use inverse tan. X is approximately 18.43 degrees. Okay, number 14, we're solving the right triangle, so we're solving for all the missing sides and angles. So with these types of problems, you're going to start with whatever you have two of. So since I have two sides, I'm first going to solve for AB. And I'm going to solve using Pythagorean theorem. So x squared plus 23 squared equals 25 squared. So x squared plus 529 equals 25 squared, which is 625. And then subtract 529. So 625 minus 529, we get 96. And then square root both sides. So x is approximately 9.80. So AB is 9.80. Now I'm going to go ahead and solve for C. So using C as my reference angle, I'm going to label my sides. So I have my adjacent and hypotenuse, which means I'm going to use cosine. So cosine of C equals 23 over 25, adjacent over hypotenuse. And to get the measure of angle C, I'm going to use inverse cosine. So inverse cosine 23 divided by 25 is 23.07 degrees. Okay, at this point you can either use triangle sum theorem or you can use inverse trig again to solve for A. So I'm just going to use inverse trig solving for A. So now using A as my reference angle, 23 is now my opposite side. 25 is my hypotenuse, so I'm going to use sine for A. So sine A equals 23 over 25. So inverse sine 23 over 25. We get 66.93 degrees. Okay, if you use triangle sum theorem, you should get 66.93 degrees on that one as well. All right, so last two, number 15. This is a multi-step problem, but for this one we're solving for angle. So what we're going to do is we're going to first solve for the shared side, and we're just going to use Pythagorean theorem. So I'm going to call that y. So using Pythagorean theorem, it's going to be 12 squared plus y squared equals 14 squared. So 144 squared plus y squared equals 196, and then subtract 144. 196 minus 144 is 52 degrees. And then square root both sides. Oh, sorry, not 52 degrees, just 52. So square root of 52. you get 7.21. So now I have this side, it's 7.21. And now I can use inverse trig to solve for my missing angle. So using x as my reference angle, 7.21 is my opposite, 32 is my hypotenuse, this bottom side is my adjacent. So since I have my O and H, I'm going to use sine. So sine x equals 7.21 over 32. And then we're going to use inverse sine. So sine -1, 7.21 over 32. So you get 13.02 degrees. All right, last one, number 16. Similar process. We're first going to solve for the shared side, which I'll call y. We're going to use Pythagorean theorem. So 16 squared plus y squared equals 18 squared. So 256 plus y squared equals 324. Subtract 256 from both sides. So y squared equals 68, and last step Pythagorean theorem, take the square root. 8.25. So now I have my shared side, so now I can use inverse trig to solve for my angle. So if x is my reference angle, 10 is my hypotenuse, 8.25 is my opposite, this bottom side is my adjacent, so OH, I'm going to use sine. So sine x equals 8.25 over 10, and then we're going to use inverse sine. We get x is approximately 55.59 degrees. Again, sorry, I did my key really fast, so I think this is why I have a bunch of typos. The key should say 55.59 on there. I have 55.49 degrees, so my key is wrong on that one as well.